So this is exercise 2 related to periodic table. Exercise 1 is about the MCQs, multiple choice questions, about 52 questions. I have already the recorded session for that. So at the end of this session, I'll share that recording of all 52 questions I have solved with other groups. You can use mic or a chat to state the answer for this. Argon is unreactive noble gas. Explain why argon is unreactive. What is the reason? As you can see, yes, Mohammed Ashraf.
Because it contains the 8 valence electrons in the outer shell.
Yeah, but better, like the same question, they might repeat. Yeah, the best answer is instead of mentioning the specific number 8, it is right that it has 8 electron. That is true. But better right, it has a full shell. Like, so here, when you write 8 outer shell electron, you will not lose a mark. But sometime they may change, like why helium is unreactive. So in that case, if you say 8 valence electrons or outer shell electron, then it will be wrong because helium does not contain 8 electron. Helium contain only 2 electrons. So the best is just mention because it has a full outer shell. If you say it belongs to group 8, that is also not right answer. You have to state a reason for that. So it has a complete outer shell or full outer shell or 8 electron in outer shell is right here because this is about argon. But if the same question was about helium, then it will be wrong. If you cannot say 8. The next, give one use of argon where we can use argon. Yes.
Sir, in the lamps to make an inert atmosphere because the lamp can burn out from oxygen.
Yes, so we can use for lamps, filament lamps provide an inert environment. Otherwise, otherwise filament will not last for a longer period of time. In question 2, for each of the following, give the name of an element from period 2, from lithium to neon. So we have to select period 2. So which is period 2 here? The period 1 contain only 2 elements, hydrogen and helium. This is period 2. So we have to select elements from this period only to answer the question. Like we can select lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. The first one, an element which is gaseous at room temperature and pressure. Like which elements are gas?
Nitrogen, oxygen, fluorine, and neon.
So this region, any answer is acceptable. You can mention nitrogen, you can mention oxygen, you can mention neon or fluorine. Any of them you can mention. As we know, like these all elements are gaseous, gas at room temperature. Then which element forms an oxide that is a reactant of photosynthesis? Reactant of photosynthesis. Yes, officer?
Carbon.
So carbon, because the carbon dioxide plus water. So we just mentioned here carbon. You don't have to write carbon dioxide as we just have to name the element. So answer here should be carbon, not carbon dioxide. Yes. The next one, an element that is a product of photosynthesis.
Oxygen.
So oxygen is a product of photosynthesis. You can use your mic, you can use your chat to state the answer. An element that makes approximately 78% by volume of air. The major composition.
Nitrogen.
So nitrogen. An element which has atom with a full outer shell electrons. We have to select from period 2.
Neon.
So that is neon. An element which exists as both diamond and graphite.
It's also carbon.
Carbon.
An element that reacts vigorously with cold water. Highly
Sodium.
reactive. So it should be a group 1 element.
Sodium.
A soft metallic element which is stored in oil.
Also sodium.
Yeah, because why? But when I write sodium, it will be wrong here. Why it will be wrong? If I write sodium
It's
here,
period 3.
yeah, it's period 3. So if I write sodium, that will be considered as wrong. Why? Because they already mentioned in the beginning of the question that I should select period 2 element, not period 3. So even it looks a very simple question, but as you can see in the beginning, they mentioned we have to select the element from period 2, not period 3. That's why it can be sodium. It should be
Sorry, Mr. It's lithium.
lithium. And even fluorine is acceptable because group 7 elements are also highly reactive. So, and fluorine is more reactive. So you can also mention fluorine. So lithium or fluorine here and here also lithium. But don't write the symbol, write the name. When chlorine gas is bubbled through an aqueous solution of potassium iodide, a redox reaction takes place. So first we have 2 iodide ions and a chlorine gas is bubbled through potassium iodide. So if I say like we have potassium iodide, Ki. So what will be the appearance of potassium iodide? It will be colorless. It does not have like the salt solutions, the soluble salt solution for group 1, 2, and 3, they are colorless solution. If it is a solid, it will be a white solid. But if it is dissolved, it will be a colorless solution. So initially it's a colorless solution. Now what we did, we bubble the chlorine. Chlorine is yellowish green gas, but we have to mention a color change in the beaker. So chlorine is yellowish green gas. When we bubble this chlorine, chlorine is more reactive than iodine, so it will displace iodine. As a result, the solution will turn into potassium chloride. So potassium chloride is still colorless. The solution turned into KCl, but it will also form another product which is iodine. And that iodine is present in water. When iodine is present in water, what will be the appearance or the color? The solution will appear brown in color. Due to the presence of iodine in aqueous, it's brown. So say the color change that is expected in this reaction.
So it's from colorless to brown.
Yeah. Even yellow is acceptable as iodine low concentration is yellow. Orange is for bromine. Actually, the color intensity depends on how the molecules settle in the mixture. So for iodine, as I mentioned yesterday, you have to learn the color of iodine, especially that if we have iodine and iodine is there as a solid, you will mention it is black or purple. But if iodine is there, dissolve in water, then two possibilities like iodine dissolve in water aqueous. Then if too much iodine is there, like concentrated iodine solution, it will be brown in color. If it's a dilute iodine solution, then it will be yellow in color. And if iodine is present in organic solvent, the iodine will appear to be pink in color. And if too much iodine is there, then it might be purple, but it's normally pink in color in organic solvent like alcohol, like propane. So these are the colors of iodine you should remember. So as a result, what happened? Because potassium iodide turned into potassium chloride, which is colorless, but iodine is formed. So due to the formation of the iodine, the solution will appear brown. So starting color of the solution, the beginning it was colorless, and then it will turn brown. We have nickel, copper, zinc are the three consecutive elements in the periodic table. Nickel, copper are transition elements. State three chemical properties of the transition element. So transition element, these are the elements. Yes. What are the chemical properties?
So, Mr. They form basic oxides and variable oxidation states, and also form colored compounds.
So form colored compound can be used as a catalyst, have variable oxidation state, or form complex compound. These are, but instead don't mention about basic oxide. The reason is that some of them form amphoteric oxides as well. So you can mention about reactivity. You can mention about the catalyst. The best one is mention about the catalyst, variable oxidation state, and form the colored compound or form the complexes. So first one can be used as a catalyst, colored compounds. Actually, the formation of the colored compound, the reason why they include in chemical properties as well, because the formation of a color is due to the movement of electron, the transition of the electron. That's why it's acceptable. Then you can write the formation of a colored compound as a chemical property as well. In the slides, I mentioned in a physical one, but it is acceptable as the formation of a colored compound involve the chemical changes as well. So forming the colored compounds and variable oxidation state. In question 5, the element of group 7 are known as the halogens. Some halogens react with the variable oxidation state, means like sometime during a reaction they can lose 2 electron, like iron might be +2. So what does it mean? It means iron has lost 2 electron. Some reaction iron might lose 3 electron, so iron will be +3. So loss or gain of electron is also a chemical change. So that's why variable oxidation number or variable oxidation state, variable valency is categorized as a chemical property. Or forming a complex compound is also another property of these transition elements. The elements in group 7 are known as the halogens. Some halogens react with aqueous solutions, halides. As you can see, complete the table. You can use screen annotation to put tick and cross. First, chlorine is added to potassium chloride. There is no reaction, so cross. Chlorine is added to potassium chloride, potassium iodide. So tick where the reaction happened and cross where there is no reaction. The reactivity, we have fluorine, chlorine, bromine, and iodine. As we go down, they become less reactive. The reactivity decreases. So iodine is less reactive than others. So iodine cannot displace, like example, if I have potassium chloride and iodine, it won't react because iodine cannot displace. Bromine cannot displace chlorine from its compound. That's why cross is there. Chlorine can displace bromine and iodine, both of them. That's why there's a tick in both of them. And bromine can not displace chlorine or bromide. It can only displace iodine. Then write a chemical equation for reaction between chlorine and aqueous potassium bromide. The chemical equation must be balanced as well. So chlorine, because it's a non-metal, so it will be Cl2 plus aqueous potassium bromide. Potassium is group 1, so it is +1, and bromine is group 7 -1. Whenever a question is write a equation, it should always be a symbolic until unless they mention write a word equation. So if a simple question is write a chemical equation, write an equation, it should always be symbolic. So we have potassium bromide. First, we don't bother about balancing. First thing, we write correct product because chlorine is more reactive, so chlorine will displace this bromine. As a result, what will happen? It will form potassium chloride, KCl, plus bromine, so it's a non-metal Br2. Then the balancing, so always like bromine 2, it's balanced, and chlorine 2 is also balanced. So this is the balance equation for reaction between chlorine and potassium bromide. In question 6, astatine is at the bottom of a group 7. So we have, yes, Muhammad Ashraf.
Sir, can I solve the first question?
Okay.
So, Mr., it will be solid because iodine is solid, and when we go down the group 7, the state will change from gas to liquid to solid.
Yeah. So as we go down, the state is changing, the melting point is increasing. So what is the state of astatine? So it should be solid. Write a chemical equation for reaction between sodium and astatine. So sodium and astatine. So again, as I mentioned, chemical equation, it should be symbolic. So sodium is Na and astatine is At. But because astatine is a non-metal, so it should be a molecule and it will form sodium acetate. So what is the formula of sodium acetate? Sodium is group 1 +1 and astatine is group 7 -1. So the formula will be NaAt. That's a product. So first we always write or try to write a correct formula for the product and then we balance. So we have 2 astatine, we put 2, so astatine is balanced. Now we have 2 sodium and here 1, so sodium is also balanced. So this was sodium plus astatine will give sodium acetate. So it's the same thing like if sodium react with chlorine, it will give sodium chloride. Sodium react with bromine, it gives sodium bromide. Sodium react with iodine, sodium iodide. So sodium react with astatine, it will be sodium acetate. Six different atoms can be represented as follows. So 6 different atoms are there, which are represented as follows. Use the following, answer the following question. Use the atom from the list. Each atom may be used once, more than once, or not at all. Select one atom from a 6 shown. Here exactly 7 protons. So which is having 7 protons here? So J is having 7 protons, like as you can see. So J is having, you can use screen annotation or you can also use a chat or a mic to state the answer. Has 6 neutron. How to work out the number of neutron? You take a difference between the nucleon number and the proton number. So 3 minus 1, that's 2 neutron. 3 minus 2, 1 neutron. 12 minus 6. So 6 neutrons are there. So that's why E. Has more proton than neutron. So when we check, D is having 2 protons, but it is having only 1 neutron. So it has more proton than neutron. That's why D is right. Has electronic structure or configuration 2, 7, or you can say 7 proton, 7 electrons are there or 7 proton. That is J. An atom of an element that belongs to group 7. So how we identify when we write the electronic configuration? For when you check for L, there are 9. So what is the arrangement? 2, 7. So it belongs to group 7. And is an atom of a noble gas. Means it's unreactive or has a complete shell. You cannot mention A because A is having 1 proton. A is actually isotope of hydrogen. A is not a noble gas because it should have a complete shell. So D is having a complete shell because 2 protons are there and 2 protons and 2 electrons. So it has first shell, it has complete shell, like 2 electrons. So complete shell. In question 8, a student bubbled the chlorine gas into a test tube which contained aqueous potassium bromide. So first, in a test tube, student was having potassium bromide. What is the color of potassium bromide? It is colorless. When student bubble chlorine, chlorine is more reactive, so chlorine will displace bromine. As a result, it will produce potassium chloride plus bromine. This is still colorless, but the bromine is there due to the formation of the bromine. If you have like a bromine is there, you can, if a high concentration of like greater concentration of a bromine, so it is acceptable. If you say orange, even you say brown is also acceptable. So brown acceptable, bromine, because bromine water is normally orange. Orange is also correct. Brown is also, so it's starting, it's a colorless. The solution does not have any color, then it will change to brown. Or you can mention orange, or you can mention even yellow is acceptable. The color of a bromine is either brown or orange. Only 2 colors are there for bromine. Bromine is a volatile liquid. It's a red-brown liquid at room temperature. But when we mix in water, normally it looks like orange, but acceptable brown. So for bromine, as like iodine, if we have a bromine which is liquid, at room temperature, it is red-brown liquid. When bromine dissolve in water, like aqueous bromine, this is also called a bromine water. Normally, it's a high concentration, so orange, but acceptable brown, or even when very low concentration, it appear to be yellow. An organic solvent also is the same color, brown. Yes, you have to memorize in the colors here. Then we have to write an ionic equation, complete an ionic equation. So the more reactive turn into ion and the less reactive ion turn into molecule for non-metal. So chlorine is more reactive. It's a molecule, it turn into ion. So it will turn into chloride ions. And bromine is a less reactive ion, it will turn into molecule. So this will be the ionic equation, and we just put 2 to balance the equation. So whenever we want to write ionic equation, always remember, like, the more reactive turn into ion, and the less reactive ion turn into atom or molecule. If it is for metal, it will turn into atom. If it's a non-metal, it will be a molecule. So we have chlorine and we have bromide ion. So what will happen? Chlorine is more reactive. So more reactive will turn into ion. So it will form 2 chloride ions. And the less reactive will turn into atom or a molecule, but because it's a non-metal, so it will form a molecule. And just to balance the equation, we'll put 2 here. So the equation will be balanced. The following formula represent different substances. Answer the following question. Only use these substances. Each substance may be used once, more than once, or not at all. Used to make food container. Food container usually are made from aluminium. So aluminum is the right one. This question, this was about the extraction of the metal that we will do in metal topic. So we'll skip now. The answer for this one is added to a blast furnace to remove impurities. That is calcium carbonate, but we'll do it. It is the main constituent of a natural gas. So natural gas mainly consists of methane. That in organic chemistry we'll discuss. Main cause of acid rain. That is about air topic, sulfur dioxide. A gas which bleeds the lamp litmus paper, that's chlorine, has a tendency to bleach the litmus. And a gas which contribute to climate change or a global warming, that is methane as well. Methane is having a greater greenhouse factor than other. Like carbon dioxide is can also it's a greenhouse gas, but relative effect is less as compared to methane.